In this video, we're going to focus on solving multi-step equations. We're going to use information that we know about combining like terms, and we're going to use information we know about solving equations. We're going to put these together, and we're going to be able to solve equations that look like the first one, where there are more than one term with an x and more than one number. So if we look at the first problem, there's two different terms that have x's in it. So just like we combine like terms, I'm going to put circles around these. Instead of writing 3x plus 6x, we're just going to write 9x. Our other like terms, we have a plus 5 and a minus 7. So we have 5 minus 7 is negative 2. Our equals comes down. And our 25 also comes down. So now we have an equation that looks much like one that we have solved many times before. We must look at the sign in front of the number. It's minus 2, so we're going to plus 2. We want to get this to where this portion equals 0 and it cancels out. If we do something to one side, we have to do it to the other. That's kind of the golden rule of solving equations. So now we have 9x equals 27. We look and we say, the variable, how can we get it by itself? It's multiplied by 9. So we're going to divide by 9. And we have x equals 3. Just like our previous solving in equations, we're going to go back through and we're just going to check it. So we're going to take this solution x equals 3, and everywhere we see an x, we're just going to plug in 3. We are going to use our order of operations, and we're going to simplify it down. Multiplication first, and then adding and subtracting. So I did 3 times 3 is 9. I did 6 times 3 is 18. I just brought every other term down. Now we combine. We go left to right. So we have 9 plus 5 is 14, plus 18 is 32. Minus 7, and we still have equals 25. 32 minus 7 is 25. We get a true statement at the end, so we know that this problem is correct and that x equals 3 is a solution. I want you to try the next example on your own. So go ahead and hit pause, complete the problem, check it, and then resume. The next type of example that we're going to see is one where there's going to be multiple fractions. What we want to do is we want to look at the bottom number. And we're going to see what can we multiply by to get these bottoms to cancel out. So here we have each of these is divided by 5. So if we multiply each by 5, we're going to just get rid of the fractions, and it's going to be a lot easier. Remember, what we do to one side, we have to do to the other. And we have to do it to each part. So I'm going to do it to the right side. I'm just going to multiply by 5 over 1. I'm just going to write it like this because we're going to be multiplying fractions. On the other side, remember we have to do it to the entire part. I'm also going to do 5 over 1. We're going to have to use our distributive, so we're going to have to do 5 over 1 times 4/5. We're going to have to bring down our subtraction, and we're going to have to do 5 over 1 times 2p over 5. Our other side looks like this. Once we multiply this out, the 5s, any top and bottom can cancel out. If you want to see this, why this works, you can do 5 times 4 is 20, then divide it by 5, you get 4. It works the same way. It's just a shortcut. If you look at the top and bottom and they can cancel, then we are just left with 4 over 1, and I'm just going to write 4. Same way with the 2p and the right side as well. Now we just have to solve the equation. We want to get the variable by itself. It is minus 2p. We look to the left of the number. It's positive 4, so we're going to subtract 4. Notice how this becomes 0. Whatever we do to one side, we have to do to the other. Here we're left with a negative 2p, and that equals 2. We have to divide by whatever number is in front of the variable, and we get p equals negative 1. We want also to include a check step on this. Okay, so go ahead and plug that number in, make sure that it checks out. Once you have, I want you to complete the next example in a similar way. Notice that these have different numbers on the bottom. So it's going to be a little bit different. You're going to have to think about what number can I multiply by to get all of these to cancel out. That number is going to be 6, just a heads up. Go ahead and complete that example. When you have, go ahead and hit resume, please. On the final example, it looks a little bit different. We always want to ask ourselves, how can we rewrite this to make it look like something we know how to do? So we have 15 over 8 times z. We know anything, whether it's a number or a letter, can be written as over 1. So this is really 15 over 8 times z over 1. If you do that multiplication, you get 15z over 8 times 1, or just 8, plus 1/4 equals 4. So at this point, we want to look at our denominators and say, what is a number that we can multiply both by that will get these to cancel out? This is going to be your least common denominator, if you remember how to find those. So if we look at 4 and 8, we have to think about, we look at the larger number. So if we multiply both sides by 8, and we do every part, we have this distribution. The 8's cancel out. We were left with 15z. We do this multiplication. We get 8 over 1 times sorry about that, 1 over 4. We bring down the equals, and 4 times 8 is 32. So we have 15z equals 8 over 4, or 2. That equals 32. And from there, you're just going to solve it like you have solved the previous problems. If you're having difficulty with this, please check out the linked videos, or you can Google the title of the video, and you'll be able to find multiple resources on this information.